All right, section 10.1, random sampling. Before we actually get into it, we're going to just review some basic statistics. The first one is just mean, median, and mode. So I have data points for the number of days it rained in each month over the past year. So to find your mean, you want to add up all of those values and divide by how many values you have. So when I did that, it would be 8 days would be the average number of days that it rained in each month. To find your median, that's kind of your middle ground. So you want to make sure these are in order numerically, so smallest to biggest, and then you're just going to split it in half. So since I had 12 data points, splitting in half would be 6. So I need this value in between these two guys here. So that's why I found the average. 8 plus 8 divided by 2 still gives me 8. And then mode is your number that occurs the most often. So in this case, once they're in numerical order, you can see that 9 repeated itself 3 times. Example 2 is just basic probability. So when you're doing basic probability, you want to do favorable outcomes divided by the possible outcomes, okay? So you've got a die that's rolled and a coin that's tossed. What's the probability that the die shows a 1 and the coin lands tails up? So to show a 1, so there's only one on a die. So that's why you have a 1 on top. There are 6 numbers on a die, so that's why you would put 6 on the bottom for that first part. Second part, they want a tail. So when you're thinking of a coin, there's only one tail option on a coin. There are 2 options on a coin. So then you just times those 2 together, and your probability would be 1 out of 12 that you would get a 1 and a tail at the same time. Okay, I'm going to pause the video, or you're going to pause the video and see if you can try. So I'm going to have you do 4 through 7 over here, but just do question number 3 for this very last one over here. Okay, so on question 3, you want to make sure you put them in order. So once you've put them in order, you should be finding the average by adding divided by 10, because there's 10 values. So I would get 7.7 for my mean. The value in the middle was your median. So I had 10 values. So in between here, so I'd have to add 7 and 9 divided by 2. And then the mode, the number that occurred the most, 10 occurred twice. For your probability over here, I want a 4, so there's one option for that on a die. There's 6 total options. For your heads, there's only 1 out of 2, so I times those and I get 1/12. Next one, you've got 3 odd numbers, so that's why it's 3 out of 6. You again have 1 at tails out of 2, so I times and reduce, I get 1/4. A 2 or 4 means there's 2 options I want. So 2 out of 6, heads is still 1/2, times them I get 1/6. And then on the last 2, 4, 6 gives me 3 options out of 6, times 1/2, and then simplify. So I would get 1/4. Okay, so this lesson is all about making sure it's random, and then we also want to identify if there's any kind of bias. So just making sure you understand, statistics is all about collecting, analyzing, and interpreting different data. A characteristic of a population is called a parameter. Because it's not always practical to collect data from a large population, it may be selected from a representative sample. So a characteristic of a sample is a statistics. A population can consist of all the members that are in there, and the bias is an error that would result in a misrepresentation. So maybe they are misleading you by the way they worded a question. All right, let's look at this first guy here. So they want you to be able to identify a sample bias. The Traffic Commission took a random sample of travelers using Route 15 and determined the average daily commute on this road during rush hour. So you can see over here, this is how long it was. Their commute minutes was 26.3. After viewing the results, the commission proposed expanding the road from 2 to 4 lanes, identify any bias and potential interest in the sample. So what's the purpose of this sample? Well, they want to determine if they should expand the road, okay? What bias do you see? Well, as I look over here, I notice the sample size is only 10. That is not a very large number. So in this case, I would say a sample size of 10 is way too small to accurately reflect all of the cars. So you might be wondering what would be an accurate number. So they typically say that you want about 10% of your population for your sample size to make sure that you get an accurate picture of what's going on. Last thing it asked about identifying any interests. So the bias in that sample size may lead to a sample average that does not reflect the true commute. Okay, so with that being said, this bias would serve the contractor's interests because they would win the business of expanding the road and get more money. Now, it would not be in favor of the people who have to build the roads, like taxpayers who have to pay for it. So, there's your misleading information that could occur from that. All right, the next part we're going to talk about are just different types of studies. We've got three different kinds here. We've got a survey, an experiment, and an observational study. A survey is data collected from responses given by the members of a group regarding their characteristics, behaviors, or opinions. So typically that's filling out a form, a questionnaire, or an interview. Experiment is where you're going to divide it into two randomly selected groups. So make sure you underline that word randomly because that's very important. You're going to have an experimental group and a control group. You're going to have an effect on the experimental group that you're going to compare with that control group. Okay. Observational study. This is where you get to observe people. So there's your key word for observe. So you want to make sure again that you're randomly selecting those people and then you observe that behavior. So to determine when to use each type of study, think about the data that will be obtained and how that study will affect those participants. All right. Before we identify the different studies, I guess we needed to identify this biased question here. A restaurant owner wants to determine which kinds of meals she should add to her menu, vegetarian options or more traditional meat-based dishes. She releases a survey to her customers asking the following questions. Do you prefer a plain salad or a delicious steak? Identify any bias. So what's the purpose? Well, we want to figure out which dishes are most popular. So what would be the bias? Well, do you see how the question is worded? People might pick the steak based off you thinking it's delicious versus the salad who just think it's plain, right? So instead, if they did, do you prefer a salad or a steak? That might have better results versus giving in those descriptive words. All right, let's identify different types of studies. So in this case here, a research team wants to test new football uniform designs and their appeal to young adults. They randomly select 100 young adults to view the different uniforms, and the research team observes and records the reactions to the uniforms. What's the purpose? Well, we want to see if we are going to have new uniforms that people would like. What kind of study is this? This should be observational because of your keyword here with observes. And then just bonus questions. What's the sample and what's the population? So the sample is the 100 young adults that we actually observed. The population would be all young adults. So remember, population is the whole thing. Sample is just that small group that we pulled randomly from that whole group. All right, do your best here. I'm going to try and cover these answers, but pause the video and see if you can identify which study you think goes with which description here. Okay, so a principal wants to determine the favorite after-school activity of his students. I said a survey because you would probably want to just send out some kind of form for them to fill out. A researcher wants to determine whether young adults would be interested in a new line of smartwatches entering the market. This to me says they want to observe their behavior with those, so that's why I said A. And then a teacher wants to determine whether bright colors affect the test-taking abilities of high school students. I said experiment, you're going to want two different groups. You're going to want one group that doesn't have the bright colors and then the other group that does. Now, they did throw in census. That was not in our descriptions from before. Usually they do that for population, like the U.S. Census Bureau. So they list all the individuals in the population. That's really hard to do to get that accurate. All right, couple more examples here. Can we draw a conclusion from a study? So researchers are testing different types of virtual reality goggles. Each randomly selected participant could choose a type of goggle. The researchers observe the number of people who chose each type and the number of positive reactions. Identify the type of study. This looks to be observational because you had to observe the number of people. Then draw a conclusion. So it looks like people preferred having C and D And so I would recommend that those would be the types of goggles they should produce. Last one here, identify a bias in your study. So can you identify any flaws? Experiment. A teacher wants to study the impact of music on testing. She gives a test in her Algebra 2 class in a quiet environment. She then gives the same test to her geometry class, but this time with music playing softly. Results. She found that the mean score of the test taken by the geometry class was higher than the mean score of the test taken by the Algebra 2 class. She concluded that music is beneficial when testing. So, step one, identify your different types of groups. So, your control group is going to be the Algebra 2 class that was in a quiet room. And then the geometry class will end up being your experimental group because they are the people that had the music playing. Identify any flaws. Did she randomly select these people? So, she has to be able to randomly select them. Also, the two groups have more than one difference. Besides having the presence of music, everything else should be the same. So the content is different, geometry and algebra 2. And then also, you've got people at different skill levels, right? So you've got A students with F students, B students with D students, etc. So correct any flaws. One, she needs to make sure she uses a sample size from just algebra 2 or just geometry, and she needs to make sure they're on the same academic level. Two, she needs to also make sure she randomly selects for those two groups. All right, that concludes section 10.1, where we were talking about random sampling.